Okay, exercise set 139.3. When I first looked at this section, I saw Newton's method, and I was kind of surprised to see what he was doing. He wasn't using derivatives to do Newton's method. He was using something else. Nowadays, excuse me, Newton's method is related to using derivatives, and that's what I want to go through. So I summarized the technique over here, and we're going to go through examples now. Now, of course, when we go to examples, I'm not going to do this by hand. However, in my notes, you'll see me writing down the intermediate steps of this, what the guesses are, what the function is, what the derivative is, yada, yada, yada. What I want to do is go directly to Sage, all right? So I'm going to go to my terminal, and the first thing I want to do is just reset. The next thing I want to do is I want to define the function. So let me just scroll this up a little bit so I can definitely clearly see what the function is. And we're looking for the root of the function, or where it's 0. So the function f of x is equal to, let me get that into a white space so it looks a bit clearer to you, all right? So f of x is equal to, let's see, x cubed minus 3x squared. Let's see, minus 2 times x. Whoops. And then plus 5. All right? The next thing I want to do is I need a derivative of this, so I'm going to just name a new function now. And I'm going to name that function df. There's nothing special about the name, by the way. Just use it so I can understand what I got over here. And what's f of x? I'm sorry, what's df of x? It's the derivative of it. diff f of x with respect to x. And now I'm going to define Newton's function, and I'm going to call it n. And what's Newton's function going to be? It's going to be x minus f of x. Whoops, I made a mistake. It's going to be x minus f of x. And this could be a general structure, by the way, over df of x. All right, things are going along pretty smoothly. Now, of course, I need to make a guess. Well, here's what they said. Estimate the root between 1 and 2 and near 1. So what I'm going to do is make a guess. I'm going to say my initial guess, x naught, is going to be, well, let's just make a guess. So what's a good guess between 1 and 2, near 1? I'm going to say 1.1. Okay. So what I want to do is I want to use Newton's method to get another guess. So another guess, so I'm going to say the next guess would be x1. That's going to be assigned Newton's method evaluated at x naught. And I want to display x1. I want to see what it looks like. I get that number. So I get 1.2. All right, now what I want to do is I want to get another guess, and I'm going to call it x2. And x2 is equal to Newton's method evaluated at x1 now. We'll go to the key in a moment. I want to display x2 now. And I get 1 point, it definitely changed, by the way. You see 1 is 1.2008. Now it's 1.2016. Now I do another guess. I'm going to do this until things settle down, at least within the precision of the machine, to be the same. So what I'm going to do now, I'm going to do Newton's method at x2. And I want to display x3. All right, let's look at it. There's definitely been a change. All right. Now it's getting better, but it's not the same number. I want to go x4 now. And that's going to be Newton's method evaluated at x3. And I want to display x4. Okay, no change now, right? Which is good news, by the way. Now I'm not going to continue. I'm going to say that's the root. So what I could do, I could do f evaluated at that number. I'm going to use the underscore, which means the output from the prior input. And let's see what it gives. It should give us, something really close to 0, by the way. And what does it give me? 8.8 times 10 to the minus 16th. That's a pretty good approximation now. Now, that's essentially equal to 0. Right? I want to go over the notes, though. I want to make sure this stuff is written down for you. All right? Now, let me see what the guess was. My initial guess was 1.2. And then I got the intermediate values over here. But it does come down to the same number. And you might be surprised by this. If you took another guess between 1 and 2, would it converge to that? Yes. All right, for this particular problem, by the way. All right, so that was relatively simple to do, and I'm hoping you're able to at least follow some of the code that I'm writing in here to do that. I also want to point out that when one currently mentions Newton methods nowadays, they're talking about the method of derivatives. What Wells is doing is something different, and I do go through that as well. All right, I don't think it's I think it's more difficult than Newton's method. When I say Newton's method, one with derivative, but it's still leading to the same answer, by the way. And it should. The approximate of the root should lead to the same result, all right? So I am using a computer for both methods, by the way. And if you look at the Sage code, at the end of the section, you'll see that. All right? Thank you.